So now in question 26, we have three situations of where a spring is doing work on a block, and we're asked to figure out how much work the spring does in each of those three cases. So in each case, we have a block moving from some displacement to another displacement away from the equilibrium position, and we just have to use that information. So first of all, this spring has a spring constant of 46 newtons per metre. And then in part A, the block moves from an initial position XO, which in the case of part A is just 1 metre, to a final position XF, which is 3 metres. And so the work that is being done by the spring in this case is equal to the negative of the change in the elastic potential energy. And this elastic potential energy, this change in elastic potential energy, is just equal to the final elastic potential energy minus the initial elastic potential energy, and we have a formula for those. So in this case, that change is going to be a half K XF squared minus a half K XO squared. And so for this situation here, then we could probably do a bit of simplification. We have a common factor of a half K here, so we can pull that out outside the brackets. And so this is just going to be a half times K times XF squared minus XO squared. And we can also cancel out this minus sign. So this will be this. And so just plugging numbers into this formula then. XO is 1 minus 3 squared. Oh, and so we get, in this case, I get minus 184 joules. And so that spring is doing negative work on the block, which kind of makes sense because as the block goes from 1 metre to a position of plus 1 metre to another position of plus 3 metres, the spring is getting more and more stretched. And so the spring is going to be slowing that block down, which means it's going to be doing negative work on it. It's going to be taking kinetic energy away. So this minus sign here makes sense. Now in part B, we have the same thing. It's just that here, the initial position is minus 3 metres, and the final position is 1 metre. So if we just take these two numbers and we plug them into the formula that we've already got, then here, I suspect we're probably going to get a positive number this time. So here we have a minus 3, but when you take the square of that, the minus just cancels out and we get 9 here. And so that'll be 3 squared is 9 minus 1, which gives us plus 184 joules. And then finally in part C, we have that the block is moving from XO is equal to minus 3 to XF, which is plus 3 metres. And so initially, the block is as far compressed as it is stretched in its final position. So I would expect that as the block goes from this minus 3 to plus 3, the spring will be doing as much negative work on it as it will be doing positive work. So overall, the amount of work that it's doing is probably going to be 0. So just to confirm that, let's just plug the numbers into our formula. So here we're going to have a half times K, 3 squared, so So minus 3 squared is just 3 squared. And so now we're going to have to take off another 3 squared, which gives us 0 joules, as we might have just expected.